Hello everyone, my name is Ankit Verma and today we are learning the power of sigma. The symbol which is given here is called sigma. The sigma represents the alphabet and alphabet is finite set of symbols. So here A and B are the symbols and their set is making the alphabet. From the alphabet we are going to create some languages. Let's assume the first language is set of all strings of length 0. So this language can be represented by sigma raised to the power 0. Here the length 0 means nothing and there is a special character which is denoting, that is called epsilon. So inside the set we are having only epsilon. This epsilon is also called the null string. So whenever there is nothing inside the theory of computation, that is denoted by epsilon. Now we are taking another language which is set of all string of length 1. This is denoted by sigma raised to the power 1. So here inside the set we are having those string which is having only length 1, that is A and B. We are creating another language which is set of all string of length 2 and this is denoted by sigma raised to the power 2. This sigma raised to the power 2 means we are having 2 times sigma, so that is sigma into sigma. And single sigma is a comma b. So here we are having set of a comma b into set of a comma b, and that will be equal to set of, now we are multiplying them. So a with a is aa comma a with b is ab comma b with a is BA, comma B with B is BB. So here in the sigma square we are having AA, AB, BA, BB. So set of all string who are having length 2. Now we are taking another language which is set of all string of length 3. And this can be denoted by sigma raised to the power 3. We can also write sigma raised to power 3 as sigma into sigma into sigma. So 3 times we are multiplying the sigma. So further we can write a set of a comma b and then we are going to multiply with set of a comma b and further we are going to multiply with set of a comma b. Multiplication of first two we have already done, so that will be equal to AA comma AB comma BA comma BB, and that will be multiplied with set of A comma B. Now we are going to multiply these two sets, that will be equal to set where we are going to multiply this first with A, so that is AAA comma ABA comma BAA comma BBA comma, now we are going to multiply this set with B, that is AAB comma ABB comma BAB comma BBB. So here we are having set of all string whose length is 3. The important thing is in the string of length 0 we are having 2 raised to the power 0 string. That means 2 to the power 0 is 1. So only one string which is epsilon. In string of length 1 we are having 2 raised to the power 1 string. That means 2 to the power 1 is 2. So A and B, these are the 2 string. And string of length 2 we are having 2 to the power 2 string, which is equal to 4. So here 1, 2, 3, 4. So here we have the 4 string, and in string of length 3 we are having 2 to the power 3 string, that is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So here we have set of 8 string. In the similar way, we may have the languages which is sigma raised to power 4, sigma 5, sigma 6, sigma 7 and so on, that can be till the sigma star. This sigma star is known as Kleene closure, and this sigma star is set of all possible string of all length. So if we combine all the languages, they create sigma star. So we can say that it is equal to sigma 0 union sigma 1 union sigma 2 and so on. So that will be equal to the set which is having the epsilon union the set which is having a comma b union the set which is having AA, AB, BA and BB and so on. So sigma star is the infinite language, and as it contains all the possible string, that's why it is called the universal set. All the possible languages which can be created by A and B, they are the subset of sigma star. That's why it is called mother of all languages. The next thing is sigma plus. This is called positive closure. Here in the sigma star, which is Kleene closure, we have observed that this is mother of all languages and the universal set. That means it contains all the string of all length, including the null string which is epsilon. But the sigma plus, which is positive closure, do not include the epsilon. So in sigma star, if we are not including the epsilon and whatever is remaining, that is called the sigma plus. So we can also write sigma star is equal to epsilon union sigma plus. This union is the concatenation, which can also be represented using the plus sign. So that is equal to epsilon plus sigma plus. And if we are going to take the epsilon on that side, so that will become sigma plus, that will be equal to sigma star minus epsilon. Here sigma plus is positive closure and sigma star is Kleene closure. And this is the important formula in theory of computation. So sigma star is the Kleene closure, which is mother of all languages or the universal set. And from the universal set, if we are reducing the epsilon, which is the null string, so that will become the positive closure. So that is the power of sigma. So that's all for today. Thank you.